Thank you, everyone, and good morning. This is pretty a little disorienting for me, being a University of Oregon alum at a UW podium. So
We're taking lots of pictures of you standing right there.
I'll just work my way through it. And also disorienting is talking at people. That is not my native habitat. Usually I'm sitting and having conversations more along the table. So I'll do my best in my unfamiliar habitat. I was asked to come and share WSDOT's experiences in bringing new stormwater technologies to market, so to speak. As a public entity, we're not copywriting and making money off of these things, but we are serving the public good. You'll see an overriding theme that our focus is developing solutions for linear roadway applications that are cost-effective over the whole life cycle, not just constructing it, but operation and maintenance. Is there any operation and maintenance folks in the audience here? I challenge the organizers for next year to get more of them in here. They're a really important piece of solving the solution. I used to be in operation maintenance way back in my career, seeing the planners and designers who didn't consult with me, building their innovations, that if I ever got in the position to help bring new ideas to the table, I would be involving those operation and maintenance folks, because to really make things work, it needs to work for them. So, okay, on to my presentation. So, our experience developing new technologies is not for the faint of heart. There's a lot involved, from planning, QA, QC, quality control, all the way to submitting the evaluation report to ecology for review and approval. It's run us about in the neighborhood of $250 to over $300,000 per BMP evaluated, so it's quite the commitment. So it involves complicated logistics. When's it gonna rain? It's important. We have storm criteria, and that triggers when we deploy staff. Got to calibrate our equipment, set the timing, so forth. You collect the samples. Is the lab going to be open? These kind of considerations all reside in the background. Work zone safety. Our lab is not in an enclosed environment. We're out along the roadway, and this is our lab coat. It's not a white lab coat. Safety, seriously, safety is a serious issue for us. It's very sobering when the email comes from the Secretary of Transportation that somebody got seriously injured or killed in the right-of-way setting. And this is where we're conducting our experiments. So we have to take the precautions to not only do a sound experiment, but also do it in a safe manner. There's other challenges. We have direct and indirect hits. And that includes vehicles running off the road and taking out our monitoring stations. This isn't an isolated incident, by the way, although this is probably one of the more dramatic ones. Vandalism has been an issue, theft. I guess the meth lab people really like the solar panels that keeps them off the grid. But they've taken our enclosures for our monitoring equipment. It's an issue. The right-of-way is a dynamic place. Besides vehicles moving past 60, 70 miles an hour, it's also often a utility corridor. And this picture down below here is an example of fiber optic cable installation that went right through our site as we were setting it up. But we had to make adjustments. The dynamicness of the right-of-way setting is a real issue, considering it takes a 2 to 3 year time period to do our evaluations. So, and other complications that you wouldn't normally think of. Raptors love creating nests in our rain gauges. The photo down below here, I could give a whole 10-minute presentation on that incident, but in essence, we had a delivery of compost to build one of our BMPs that we're going to evaluate, and there was more than just compost in there. This particular batch was heavily laden with litter, plastic, styrofoam, pieces of tire, candy wrappers. It gave us insight, at least it gave me insight and some of my colleagues, to the compost manufacturing process, and it gave us reason to pause about the application of the compost, and we've had some really good conversations with the compost manufacturers and ecology to try to remedy situations like that. I had a video of this that went pretty viral, and word got to the compost manufacturers pretty quick, and so that led to good conversations, but I was hoping this was an isolated incident, but it wasn't. There was situations where they were finding hypodermic needles in the compost and so forth. So another presentation another time. So a big part of our heritage in BMP experimenting is the development of the Lake Union Ship Canal Stormwater Research Facility. And this was in motion before I came to DOT in 2002. It was set in motion in the late 90s. And the vision was to develop a facility to verify the performance of vault-type BMP applications, kind of BMPs you could put in a box underground. It was envisioned of offering an opportunity for proprietors of these systems to have a place where they could have their products evaluated. There was also the thought of establishing a verification program around this. As a partnership, WashDOT's role was construct it, manage the site. Other partners were to coordinate it, try to bring in the money, get the proprietors interested in it, involve the universities in analyzing the data, so forth. It's quite the facility. Construction was completed in 2001. It drains about 32 acres of primarily I-5, mostly pavement, but there were some vegetated areas. And there's 4 test bays, so you could test 4 different systems. But it failed to realize its dream. In short, what turned out to be an effort to the collaborative research turned out to be a discovery of the challenges involved in collaboration. As soon as the facility was operational, the funding shortfall started to occur, and some of the project partners couldn't meet their commitments. And in the end, I think we only had one BMP go through the full evaluation process at this facility, largely with a partnership of the city of Tacoma. Another thing was kind of playing in the background. Regulatory forces almost overcame the events, at least for WashDOT. The move to proprietary vault-type solutions wasn't something that wasn't something being embraced by the services. They wanted to move to more green infrastructure. This facility wasn't really set up and designed to evaluate those types of BMPs. So WashDOT itself, priorities and interests moved on to elsewhere. So these are some of the other elsewheres we moved on to. This one is probably one of our most recognized successes to date. It's the media filter drain, previously known as the ecology embankment. We keyed in-house, we named it the ecology embankment to help get it through the ecology approval process easier. But it's essentially a treatment drain, and it requires sheet flow flowing off the pavement. The first part of it is a gravel no veg zone to keep the flow and sheet flow so it doesn't channelize. It's very important for operation here that it doesn't get channelized. Then flows through a vegetative filter strip and then into an engineered mix for further treatment. What was special about this BMP is it provides a cost-effective treatment for metals removal in a linear application. Up until this point, the tools in the toolbox for us weren't cutting it. So this was big. It was an interesting odyssey getting this through the approval process at the time. This was, the tape process was manned or staffed by an ad hoc group of changing faces. And so it was a real cumbersome process. People came and went. And I think it took longer than it does. Well, it did take longer than it does now because of that. Next success, more recent, compost cemented biofiltration swale. This is an example of an evolution, not a revolution, an evolution of a BMP technology. Taking a standard biofiltration swale and how could we improve the performance to get it to be more effective in removing dissolved metals. Pretty simple. This one turns out to be. Add a 3-inch compost blanket over it, apply vegetation, water, and let it grow. And this type of application is really meaningful for WashDOT because of its retrofit application potentials, low-cost retrofits. This one is in the pipeline. This is a modified media filter drain. So the first one you saw was for sheet flow. This was developed, this came up in a situation for I-405, where in a highly urbanized area, there wasn't even a place for that small footprint standard media filter drain. So this actually was an example of iterative adaptive management. It took four iterations of design before they came up with a design that was going to meet the performance goals. But essentially, instead of a gravel spreader and a filter strip, that's substituted by a detention pond. So you get the settling out there, and the polishing occurs at this contraption below with a dispersal pipe, and then you have the media and so forth. It's in the hopper. This is 8 years in the making. It's right now in the approval process. About $300,000 just for the monitoring aspects of it. So hopefully we'll get word shortly. And so there's a lot more to talk about, but I think my time is up here. I appreciate your attention.
What are you talking about this guy? This guy is methylcellulose. The molecules you see here, it's a single mer of methylcellulose. You see 5 oxygens hanging out, doing good things. This guy has 3 terminal hydroxyl groups. We'll talk a lot about those guys in the next few minutes. So what we're talking about today is bringing a new stormwater technology to market, and we're kind of the local kids in the process. What we're doing specifically, we have a small manufacturing facility in Tacoma, Washington. You may have heard of that place. We also, the initial client which led to the development of this product was also a Tacoma resident. So we're going to talk very quickly about how we got here and where we're going and what the bumps are along the way. Oh, yeah. Technical and economic problems, hurdles to overcome. I think we're at very much where we were in the 1980s with RCRA, that our industrial clients, and I deal primarily with industrial clients, are pretty much in denial that the stormwater rules are real and here to stay. So the most common response after explaining the technical options to many of the clients is, oh, hell no. So we're going through that process and everybody's experiencing the shock of it all, but eventually come around to the fact that this is a real situation that has to be dealt with. There are stringent limits, complex regulations, some uninvited guests to the party. The CWA lawsuits are a major factor in the whole landscape of the stormwater implementation process, and high perceived cost by the client. So ultimately, we end up with a very frustrated, regulated community. And I think I've noticed there are several consultants in the room who are probably all familiar with that. There's some barriers to entry. The benchmark limits are on the edge of technology's capabilities right now. From what we've seen out here, yeah, thanks. From what we've seen out here, the parts per billion benchmarks for metals is one major hurdle that people seem to have difficulty getting their head around. Nitrates and phosphorus limits in very space-constrained environments. So a lot of this is we're talking about retrofitting treatment into an environment that's already completely built out. So urban environments, all paved, all with roof, no green space. So infiltration is rarely an option. Using soil-based treatments are difficult, swales and what have you. Turbidity in suspended solids, TPH, is another ongoing issue. Tends to be a lot of variability depending on the level of industrial activity. There seems to be some downward pressure on the limits now through lawsuits and other means, fish consumption being one. We're mostly limited to non-chemical options because of a fairly onerous chemical approval and maintenance process associated with the Department of Ecology. And we have limited space for detention and retention systems. So the bad news is that market acceptance in the stormwater treatment world is very slow and very, very expensive. As my clients frequently remind me that it's raining for free for a very long time. So the current technology deals with, there's a lot of options out there. Sorption is a very common one. Ion exchange has been applied in a lot of applications, and we have used ion exchange in some applications. Co-precipitation through one means or another. There's media filters for suspended solids and coagulation. Electrocoagulation has been broadly applied now. And for nutrients, sorption and uptake is pretty much the only game in town. The problems we're dealing with now is we've got a series of tools that do one or two things at a time, but we really need tools that can do multiple things in multiple modes in a very compact space. We're going to do a case study of how we got here. I did not wake up one morning and go, I want to build stormwater systems for a living. What happened, our business grew out of an express client need and what we believe to be some opportunities that grew out of that. One of our clients is Rainier Ballistics in Fife. They received a notice of intent to sue from a unnamed attorney and the Waste Action Project, which is an environmental group in Seattle. We were retained to assist to find a cost-effective solution for their application and review the available technologies. Problem being that we're dealing with about a 1.1 acre site, very constrained space-wise and financially constrained. The guy did not a lot of money available to do stormwater treatment. We looked at different types of ion exchange, biomass, looked at some of the commercial options that were available, and I got that same answer back about, let's try something else. Let's see what else you can come up with. So we were given the challenge of finding an alternative solution. So after a bit of experimentation and a lot of long nights, we came up with a engineered biomass product we now call Empyrean. The product development cycle is pretty interesting. The client's copper and zinc ranges were 80 to 200 milligrams per liter. So zinc is a relatively easy metal to treat. Copper, on the other hand, has benchmark limits of 14 parts per billion, or micrograms per liter. The ion exchange seemed like a reasonable alternative. We applied an ion exchange solution on the bench to expand the performance of that system to full scale, and it turns out to run about $1,000 a week, including materials and regeneration, not including capital cost. The client himself was not too concerned about the initial capital cost, but the ongoing regeneration expense was horrific for him. We looked at different biomass absorbents that were available. And we looked at compost, and we've heard a lot about compost already today. This was back in 2011, before the Cedar Grove enforcement for phosphorus, and we were concerned about nutrients, but we were more concerned about the uncontrolled presence of the things that we were finding on the side of the road, including pesticides, herbicides, syringes, all of the challenges that can be in an uncontrolled commercial environment. So we went with a different approach, and I think Kurt did some work with Port of Seattle in using soybean hulls as an original media. So we thought, let's try some of this stuff, and so we got an array of everything from soybean hulls to corn cobs to spent hops, among others, and we started experimenting with making these things work, and we got reasonably good performance out of them. But the mechanical properties of this stuff, I mean, soybeans turns to mush after a very short period of time. It performs very well for a period of time, but hydraulically it's a mess. So we started playing with other stuff that was more attractive hydraulically, hence our friend methylcellulose. Okay, this guy has 3 terminal hydroxyl groups. Each of those guys provides us an opportunity to have some fun with them, make them play well with others. So what we want to do to these hydroxyl groups, metals, of course, especially the regulated metals, are divalent. They have a +2 charge. So they have a concentrated charge in a very small space. Well, those little hydroxyl groups give us an opportunity to attach different critters that we want to attract divalent positive ions. So sure enough, we play on the bench. We have this idea. I pull out my little chemistry kit, and I get to play with my models, and I go, aha. And after a few iterations, we found a formulation that actually is remarkably good at absorbing heavy metals. We could even make it better than we're actually making it now. We can grind it into really small pieces. That makes it work better. We can do some thermal reactions and make the reactions go further. We can do multiple stages. We found that drove the cost of the material exceptionally high. So what we did is we made more cheap stuff. So that's where our process became modular. So we didn't know, okay, now we've got a solution. We go to the client, we say, okay, we've got a solution, here's a box of it, congratulations. But we didn't know how well it would work or how long it would work. So our solution to that was to put a bunch in a series, and when it worked well enough, we'd stop. And when it stopped working, we'd take the first one out of the series and move that out, put a new one in the back, and scoot them all over. And lo and behold, we had a viable process that was relatively inexpensive to operate and fit in a compact space. So that's how we got here. What we do now is we have designed the system, and we're well into the tape process. Thank you, Kurt. And we're going through we have a conditional use level designation now for metals and suspended solids. Now, each of these dudes holds about 800 pounds of media as it lives right now. So we can only do about 50 gallons a minute per series, which is a little bit more than an acre would require in downtown Tacoma, for example. So every acre requires a series of these dudes. So 2 acres, 2 series, 3 acres, 3 series. But the neat thing about that is you can rearrange in any configuration you need to meet the limits, to meet your footprint requirements. And the advantage of that now is you no longer have to have centralized collection. So that's another advantage of accidental advantage. So again, we didn't wake up in the morning and go, stormwater, that's for me. But here we are. So this is the initial data from Rainier Ballistics going back to 2011. We built, our first prototype was a big tube. It looked like an ion exchange column, which worked beautifully in a very small footprint, but you go out to change the stuff and you end up with a big plug of mush. So that didn't work so well. Our media actually doesn't look any different after a year in the field than it did when going in. First layer, the first column gets a little yucky, as you might imagine. It has all the stuff that you found on the side of the road. Anything that went in the storm drain is in that first column. That lasts however long it lasts, typically about 3 months, 3 to 4 months. We have had people have first columns last 6 months so far, so that's kind of cool the way it works. When we went to the larger bulk containers, the final design, we got better performance, longer retention time, and we're able to control the amount of treatment we had by adding or subtracting columns in the series. And you see the little zinc line here is kind of interesting. We start to see the aging phenomena of the columns in series. That's an asymptotic curve, and it reaches an equilibrium that's different at each site we've tried. So it's behaving like a chemical process. How cool. So the second system we installed had very high zinc concentrations. So we were able to pull those down in the 98% range typically. So that's good news for people. This particular guy was a metal fabrication facility, mostly making HVAC equipment. They had a little bit of copper problems, but relative to their zinc problem, it seemed like a slam dunk. Bad news is copper is harder for us to treat. So we build our systems based on how much copper is in the system, and almost nothing else matters. So because of the low benchmarks, if we treat for copper and copper is present, if we can get to copper limits, everything else seems to work. So that's our design criteria in most cases. So the hard part for us, yeah, we got a process. We have kind of this moral responsibility now to the client saying, okay, we built you a process. Now you have to maintain it. Great, how do we do that? So we call our friends at City of Tacoma, bless Alan Applin and his people. Mike Kennedy, thank you. We got a sewer permit for discharge in a relatively short period of time. I'll say that again. We got a sewer discharge permit in a relatively short period of time. So we needed to get some RODI systems set up because we have to rinse these things a number of times to get to the conductivity of stormwater. We can't put stuff out there that's more contaminated than stuff we find in the ground. The cleanest stormwater we've ever found in a conductivity sense has been 10 microsiemens. So to get there, we do a multiple rinse after the process. And I think, Ed, correct me if I'm wrong, we got 6 rinses or 7 rinses after the final step. 7 bed volumes of DI water to get to our final concentration. So that changes a little bit, but that's pretty darn clean stuff. But it takes a lot of water. We need a capital to build the process. We need a trained workforce. Along comes tape approval. Okay, so to really have the good housekeeping seal of approval in Washington State, to walk into a client and have any credibility, tape is a critical part of the deal, like it or not. So we are well into the process of that. Now we need materials, websites, data for sales efforts. This is, as you were saying, this is not for the faint of heart. So a new process going into the stormwater manufacturing business is not an easy proposition. So congratulations to those of us that do it. Calvin, you're a rock star. Staying in business is the hard part. So getting in business and staying in business is the hard part. Not just the technical, not just the regulatory, but the day-to-day nuts and bolts of it. This is the 2-column system at Dairygold and Issaquah, recently started up, as that's what they look like in the field. You'll see, we're very proud of this fact that it takes up a little bit more than 1 parking place for a 2.6 or 2.7 acre site. We can make it bigger, smaller. We may be adding more as they add more roof drains to the system, so it's flexible even on the client's basis. So it's not one size fits all. So I'm going to make this happen again. This guy is combined with other existing technology. This is a foundry on Harbor Island. You have a series of columns. On the left is a shipping container. Inside the shipping container is a Yardney sand filter. So to take out some of the particulates, you know, the foundry sands and the metal fines. And oh, by the way, that little that architectural feature in the background is the West Seattle Bridge. So lots of surprise visitors in your stormwater runoff as well. So we're able to combine our metals treatment with existing technologies, off-the-shelf technologies, in-ground water separators, what have you. So it's robust and darn flexible, and that's basically what we're bringing to the table. Here. Okay, so short term, this quarter, Rainier Ballistics should achieve continuous attainment. So 8 quarters of continuous attainment for them. Client number 2, again, same deal. We've had 100% conformance with DMR requirements. We got tape COLD in August. We showed good reduction in metals. good reduction in suspended solids. We actually have good reduction in phosphorus, but kind of trying to scratch our head and figure out why phosphorus is working so well, but it works. Patents, trademarks, all the other stuff that goes with being in business. All of this costs a tremendous amount of money. So it's a difficult and arduous process to just play in this sandbox. We seek to be a low-cost, competent provider of relatively functional technology, and it's not as easy as it sounds. So looking forward, our quality assurance plan, we'll be talking a lot. We're getting our quap together. We're going to try to separate the Empyrean from lean environment, because basically we're a little five-guy consulting firm. We like being a little five-guy consulting firm. So we're going to take that and put it in a separate box and let them go play. The QAP involves a fair amount of data gathering, site selection. Hopefully we'll find somebody with all the criteria. And we're going to focus on our existing customers first, because again, there's the moral responsibility of actually providing good service as or more important than growing the business. Staying in business is an important proposition, and staying married might be a good idea too. Most of us want to have balanced lives out there, but running a small business and doing a lot of plumbing in the daylight hours is also a challenging thing. And thanks to the team out there for your contribution to that. And we'll also develop new products to meet client needs. These guys, one of the things we're thinking about, we're kind of a one-trick pony in a sense with our metals treatment, but there's lots of opportunity to do other things with this guy. So we can pop on, an amine, and we want one of our problems here. I'll show you our words here. Is one of our problems is anionic zinc, zincates. Okay, it's present in hydraulic fluids, used as a corrosion inhibitor. In my Genie days, we had lots of that running around in the parking lot. Bad news is this stuff doesn't work so well on it. So we need to find a product or make a modification of this product that works on anionic zinc. So that's what we're working on. That's the kind of problems we face. So very grateful for your attention, and we'll be here for the rest of the day. Thanks.
My name is Chris French. I'm with Filter Bioretention Systems, and I was asked to kind of talk a little bit about our experiences with bringing our technology to the marketplace within Washington State. And we're going to try to keep this presentation fairly brief. I'm not going to go into the hardcore data aspect of things, but more about the process of our interactions with the Department of Ecology as well as with the Washington Stormwater Center. Okay, how do we... Let's see, okay, I'm actually using a remote here. Technology challenged, apparently. So just very briefly, I figured I would just cover a little bit about what we are as a company, the technology that we actually have, and then a little bit about the process that we went through with working with ecology and the Stormwater Center. But Filter is a pre-engineered rain garden or bioretention treatment system that consists of these various components. Like traditional bioretention, you're going to see various things like a hardwood mulch, pre-treatment area, engineered media, under-drain stone, an under-drain area to discharge water that has been treated prior to it being discharged into some kind of conveyance system, whether it's MS4 or something else out there. So primarily our systems have been traditionally found within concrete vaults. That is what has been approved within the state of Washington. In other markets, we are now going to a boxless bioretention system that allows folks to also get infiltration in addition to just water quality treatment, which is what our box system primarily does. This is an example of how the system actually works. In this particular model configuration, you actually have the treatment box on the front end that gets the water quality volume that you're looking for. When you achieve a rain event that gets more volume than the actual water quality volume that's desired, the system will externally bypass to a drop culvert just downstream of that system, depending on various site designs and aspects. Our tape experience here in Washington, we actually did our research study here in Tacoma at the Port of Tacoma. So a lot of that aspects, we do have a good local background in having that experiences. and working with some of the players that are here today. The protocol, as folks are aware of, is underneath the Department of Ecology's TAPE protocol. It's the 2008 version of that protocol that was out there. That has since been revised to a new version, I believe 2011, 2012. And we hired Herrera Environmental Consultants to be our principal investigator for that effort. At Port of Tacoma, we utilized two different units that were both individually monitored. The data from that particular site, in addition to supplemental laboratory data, was utilized for us to be able to get the approval with the Department of Ecology. Like many aspects, as Larry mentioned earlier and everything, stormwater monitoring is specifically challenging. It does have a lot of issues associated with it. It's also a very expensive proposition for anybody to get into. So I will also echo earlier comments that this is not something for the faint of heart. It is something that is labor intensive in addition to equipment and analytical expense, very high analytical expenses associated with that. Some of the challenges that we face with the site of Port of Tacoma is that we didn't get the high flow rates that we were hoping to get through various laboratory studies that we've conducted, as well as other field studies in other parts of the country. Just nature happened, we just didn't have the intense storms that we were looking for in that regards, and so we didn't have that aspect of it. We also saw some lower concentrations of pollutants that we were hoping to get higher and better results from, such as total phosphorus. At that time period, the protocol for TAPE didn't allow for what was called discrete sample collection, so you could target specific pollutants based off of various storms intensities, and so we didn't have that opportunity available to us to be able to work the field collection protocol to the pollutants we want to get in addition. But overall, it was a very good study. It gave us exactly what we wanted to get for the most part. And in December 2009, we achieved general use level designation from the Department of Ecology for TSS, which falls under the basic criteria, enhanced, which is your metals, and then your oil and grease constituents. In addition to that, we also got conditional use designation for phosphorus. With conditional use, you're limited to about 10 installations in the state. You have to monitor those sites, whether it be the actual manufacturer or the locality that would install that system. One of the interesting aspects that came out of this particular study is that we actually received very positive data that challenges some of the scientific understanding and backgrounds regarding the concept of irreducible concentration levels. Historically, a study that was done through the Center of Watershed Protection back in the mid-1990s basically came out and said that for TSS, irreducible concentrations were typically around an area of 20 to 40 milligrams per liter. And in this particular study, what we were able to actually see is that even though we were getting influent levels that were within that range, we were still getting very effective reductions in the TSS levels that were coming out of the Filterra units. And so there's a really neat opportunity to kind of further explore these things. I think that this is something that may need to be looked at from a broader scientific perspective in regards to all stormwater technologies, but in this regards, we got some really neat results that we were very pleased about. We've had a very good experience with the TAPE program, and that effort has continued to evolve. Over the past year, we also got into some discussions with the Department of Ecology regarding model configurations. Specifically, we have different units that are available. The water's conveyed into the system's a little bit different than the standard Filterra system. It might come in through a weir tray of some sort to distribute the water into one unit so you can have internal bypass within that system. In addition, you might have other units that might have internal bypass, but the water comes in through a pipe system so that you can connect it to downspouts or any kind of other pipe system that might go to the treatment system. At that time period, we did not have, Ecology had signed off on those designs, and they raised some concerns about those particular issues. Through discussions with them, ultimately what we worked out is a solution. Rather than go out here and individually test every single model configuration, because there was precedence ahead of time that another manufacturer had different model configurations approved without that kind of testing. What we agreed to with Ecology is that we would provide hydraulic studies of the units that actually show that there was no premature bypass of those systems before the annual rainfall was actually treated. And so in that regards, we were able to provide a lot of that research already. We had a lot of that research prior to making these systems available for the marketplace already to begin with. That was part of our due diligence in making sure that our R&D department made sure that we were actually achieving the performance claims of the systems before we released the product to the marketplace. And so we were able to utilize a lot of the existing research we had already. There was 1 or 2 additional laboratory studies that we did conduct in order to go out here and to prove that the hydraulics worked and that there was no premature bypass. So what this really was, it's a good example of how we worked with the regulator in order to come up with a resolution that really met the intent of the program as well as avoided some unnecessary field studies. So our latest exploits with working with tape is that we've just recently conducted and finished up our second field study within Washington State. We're in the process of working both with Ecology and the Stormwater Center on the finalization of that review process. And there's going to be more to come regarding that in the near future, but this is going to get at some of the issues that we identified with the first study here in the Port of Tacoma. So we'll be able to effectively be able to treat and address some of the constituents that we were hoping to get the first time around, but site conditions didn't allow for. With that, I want to thank everybody for the time, and I'll be happy to answer any questions you might happen to have.